Hey everybody, thanks for clicking on this video. Today we're going to be solving quadratic trigonometric equations. If you want to follow along with this worksheet, we have links in the description below for all the companion worksheets so you can print them off and download them if you need to. Also, don't forget to click that subscribe button so you can stay up to date on all the videos we have coming out from the channel. Now looking at this equation, we've got cosine squared and we've got cosine. And anytime you see an equation like this, people often tend to freak. And really you don't have to, because here's what we do. It's sort of hiding another problem underneath. And so what we're going to do is we're going to substitute. And what we have is we have cosine, and cosine is actually kind of in our way. So we're going to substitute cosine of x for something else. We're just going to call it y. Then you can use any letter you like. So if there's some other letter that's your favorite, go ahead and use it. So cosine squared, I'm going to substitute for y squared. And plus 3 cosine, I'm going to substitute for plus 3y equals negative 2. Now taking cosine out, now what we see is, well, this is a quadratic. Okay, well, we can solve that. We solve a quadratic by getting it equal to 0. So we're going to add 2 to both sides. So y squared plus 3y plus 2, that's going to equal 0. Now that it equals 0, now we can factor this. So we break this up into two binomials. And so we have y squared, so that's going to break into y. And plus 2, that's going to break into plus 1 and plus 2. Now when we have two quantities that multiply to 0, that means that either one or both are equal to 0. So that means y plus 1, this quantity, equals 0, or y plus 2, this quantity, equals 0. So now we can solve this equation, first this one by subtracting 1, so y equals negative 1. Over here, we can solve this equation by subtracting 2, so y equals negative 2. So what we've done is we've solved this quadratic. But wait a minute. We started up here, and the first thing we did was substitute and let y take the place of cosine. Well, what we do at the end of the problem is we reverse that. We say, okay, cosine can now take its place again. So cosine of x equals negative 1, and cosine of x equals negative 2. So even though this is a trig problem, cosine really sits out for most of it. It really doesn't go through much of this work. So now all we have to do is look at our unit circle, and I'll add a link in the description for the unit circle worksheet that we have so that you can quickly reference it. And so we need to know, when is cosine negative 1 and when is cosine negative 2? Well, cosine is negative 1 at pi. Now what about cosine equaling negative 2? Well, actually, that never happens. That doesn't happen because on the unit circle, the cosine ratio is the x value, and the smallest x value that you see on the unit circle is negative 1, which happens at pi, which is this answer. And so because negative 1 is the smallest it can be, this just doesn't give us any answers. All right, so looking on to the next one, here we have another quadratic. So we need to make a substitution again. So we substitute, and here we have sine of theta. Sine of theta, and I'll just use y again. So this is, instead of 2 sine squared theta, this is 2y squared. 5 sine of theta is 5y plus 3. So again, we've got a quadratic. Now we want it equal to 0. So we're going to subtract 5y on both sides and subtract 3. So that means 2y squared minus 5y minus 3 is going to equal 0. Now for this one, what I'm going to use is, instead of factoring, I'm going to use the quadratic formula. Because oftentimes factoring can be hard when you've got a number in front of x or y squared. So the quadratic formula says negative b plus or minus the square root of b squared minus 4ac all over 2a. Now in this problem, 2 is A, negative 5 is B, and negative 3 is C. So that means x for this problem is going to equal positive 5 plus or minus the square root of b squared. So negative 5 squared is 25 minus 4 times a, which is 2, times c, which is negative 3, all over 2a, which is 4. All right. So let's simplify inside that radical. So 25 minus 4 times 2 times negative 3. Now I'll just give this to my calculator and it'll crunch that for us real quick. And we get 49. And thankfully 49 we can take the square root of. That's going to be 7. So we have 5 plus or minus 7 all over 4. So we have to break that up. We have to break that up, and actually I should be using y here, my mistake. So 5 plus 7 is 12. 12 divided by 4 is 3. And then 5 minus 7 is negative 2. Divided by 4 is negative 1/2. So now we've got y by itself, which means that we can substitute sine back into the problem. So sine of theta equals 3, and sine of theta equals negative 1/2. So looking at our unit circle, we want to know where's the y value 3. Well, that doesn't happen. So this doesn't give us an answer. So this never happens. And then when is sine negative 1/2? Well, that's in the third and the fourth quadrants. That happens at 210 degrees and 330 degrees. And so those right there are our two angles. Note that in the start of the problem, it told us to look between 0 and 360 degrees. So that indicated that we wanted our answer in degrees, whereas up here, this was between 0 and 2 pi. So that told us we wanted it in radians. So this is how we attack a problem that is really a quadratic. We just substitute out sine or cosine, and then we solve the underlying quadratic. Once we get it solved, then you can use factoring like we did in number 1, or you can use the quadratic formula like we did in number 2. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.